lesson we're going to focus on is a new form of writing a linear equation, and it's y minus y1 equals mx minus x1. That's the new form we're going to learn today. But let's do a quick recap of the two other forms we've learned. So the first was called the slope y-intercept form, or it's just called the slope-intercept form. Okay, so recall that this form was the y equals mx plus b form, and it's called the slope-intercept form because m represents a slope and b represents the y-intercept. All right, y-intercept where the graph crosses the y-axis. Then we talked about the general form, which was also called standard form. So general form or standard form. This was the form where everything was moved to one side of the equation and the equation was equal to 0. So ax plus by plus c, and it was equal to 0. We have to make sure a, b, and c are integers, so no fractions. And as well, we make sure that a is kept positive. All right, so those were the two forms we've looked at so far, and we also were able to go in between the two, back and forth between the two forms. All right, so let's take a look at our next example here, our investigation on the sloped point form. So I'm just going to bring this in here, and we're going to take a look at this first investigation. All right, so we have a graph in this form, y plus 3 equals 2, bracket x minus 1, and it's been graphed here. And what we can see from this graph, we can easily determine the slope of our graph just by going to 2 points and looking at our rise over run. So let's calculate our slope here. First of all, the line is going up, so we know our slope is going to be positive. We'll use these 2 points here to calculate the slope. So our rise is 1, 2, 3, 4, and our run is 2, 1, 2. So since our slope is 4 over 2, that can be reduced to a slope of 2. Next, list the coordinates of point A. So our point A is here. The coordinates for it is 1, negative 3. So what we can see here is using this point A and using our slope, we can kind of start looking at a pattern. So the equation of the line now was y plus 3 equals 2x minus 1. This 2 still represented little m, the little m which represents the slope. Next, take a look at these 2 points here. We have the positive 3 and the negative 1 here. All right, so point y1 is equal to 3, which was here. So y minus negative 3, which gave us positive 3. And from our equation, x minus negative 1, our point is positive 1. So x minus 1. Let's take a look at our next example. All right, this line is y minus 1 equals negative 2 over 3x plus 4. Okay, so that is the equation of our line. So it's going down, so our slope should be negative, which it is if we look at our m from our equation. So just looking at our slope, down 2, that's our rise, and our run is over 3. 1, 2, 3. So our slope is negative 2 over 3. Next, the coordinates of B. So B is right here. The coordinates for that is negative 4 and 1. Negative 4 and positive 1. So if we look at our equation, y minus y1 equals m, x minus x1. Our slope is still represented by m, just like that. And our coordinates, -4 and 1, are represented here. All right, so y minus 1, and then x minus -4 becomes x positive 4. All right, so anytime we're looking at a graph of a linear equation in this form, the slope point form, the little m still represents a slope, and our x1 and y1 here are is a point on the line. Okay, so our next example here is we have a line given to us, and we know that it has a slope of 2 and it passes through a point A, 1, -3, which is shown right here. Double check our slope. We can use a point right here. So our rise is 2 and our run is 1. So 2 over 1, our slope is 2. So what we're doing here is figuring out what is the equation of this line. All right, and so since we do have a point on the line, and we can use any point on this line, but we're specifically looking at A, and we also know our slope, we can use our slope formula. So we call our slope formula rise over run. We're using this point here and this point here. All right, so that becomes y minus -3 and then x minus 1. And that gives us our slope of 2. Now what we can do is cross multiply that, which is done here. Y plus 3 over x minus 1. I'll just show that. All right, so when we were looking at y plus 3 over x minus 1, it's equal to 2. So we can use a cross multiplication. So just assume that this is over 1, and we'll just use cross multiplication. So y plus 3 times 1, that's just y plus 3. And then we cross multiply these two, so 2 times x minus 1. All right, so we end up with this equation here. If we multiply this out, that becomes 2x. Excuse me, 2x minus 2. All right, and we can take this a step further now and put it into y equals mx plus b form. You just have to subtract 3 on both sides. So we end up with y is equal to 2x. -2 minus 3 is minus 5, so 2x minus 5. All right, and I'm just going to show the graph one more time. But from our y equals mx b form here, our slope is equal to 2, and our y-intercept is -5. So slope is positive 2. That means our line should be going up, and it should be crossing at -5 on the y-axis. So if I bring this graph back, show that graph again here, a slope is positive 2, and the graph is going through the y-axis at -5. All right, so this equation, which we got just from knowing slope and a point on the line. Okay, so this form, which is called the slope point equation of a line, y minus y1 equals mx minus x1. Very useful when you have the slope of a line and the coordinates of any one point. So let's take a look at our example. So let's say we have a point on the line at 6, 5. And let's say we know that our slope is equal to 3. Okay, so since we know these two pieces of information, we can put our equation of our line in our slope point form. All right, so y minus y1, so y minus 5, the 0.5 here. So again, this is our x, this is our y. Equals to m is 3, and then x minus x1. So x minus 6. And that is it. We have now put our equation of a line in our slope point form. If required, you can change this using your algebra to convert this to y equals mx plus b form as well. Let's take a look at our next example. In this example, we are given a point 1, negative 1, and our slope is equal to a negative 4. All right, so using our formula again up top, we can put our equation into this slope point form. All right, so y minus negative 1. Y minus negative 1 becomes y plus 1. Our slope is 4. And then x minus 1. And sorry, our slope was negative 4. Just have to put a negative there. All right, and that's it. Our equation is now put into slope point form. Let's look at another one here. We are given a point on the line, negative 9, negative 8, and our slope is 1 over 2. So same thing here, y minus y1. So y minus negative 8, that becomes y plus 8. And our slope is 1 over 2. And then x minus negative 9, that becomes x plus 9. All right, and that's it. All right, so our next example, we're given a slope and we're given the point on the line. We're going to use our slope point form to get our equation of the line, and then we're going to put it into the slope y-intercept form, which was the y equals mx plus b form. All right, so using this information, this is our y, this is the x. So I'm just going to make a note of our equation here again. Y minus y1 equals x equals m, x minus x1. So our equation becomes y minus 2 equals 5. That's our slope given to us. And then x minus x1, so x minus negative 5, that becomes x plus 5. So it looks like that. Now, to put it into y equals mx plus b form, or it's called the slope-intercept form. So we'll multiply this out here on our right-hand side. So y minus 2 equals 5x plus 25. All right, and now we just have to add 2 to both sides. Add 2, and we end up with y is equal to 5x plus 27. So that just canceled out there. All right, so now that we have it in both forms, all we know from this form now is the slope is still 5, but here our y-intercept would be at positive 27. That's our y-intercept. So just another piece of information we can get by putting it into this form. All right, let's try another example here. We're given a slope of negative 7. So knowing that, we know our line is going down. And our point on the line is at negative 3 and 4. Okay, so let's use our slope point equation. So y minus 4 is equal to negative 7. That's our slope. And then x minus negative 3. X minus negative 3 will become x plus 3. So that's what our equation looks like in the slope point form. And we're going to now put it into our slope intercept form. So multiply this out on the right-hand side. Becomes negative 7x minus 21. And now we just have to add 4 to both sides. And that gives me y equals negative 7x minus 17. All right, so our slope is still the same. Our slope is still negative 7, just like we were given in the beginning. And we know that our y-intercept is at negative 17. So this next example, example number 3, John and Nikki were solving the following quiz question. Determine the equation in general form of a line with a slope of negative 2 passing through the point 3, negative 5. So John could only remember the slope y-intercept form, and Nikki remembered the slope point form. Complete their work, which is started below. All right, so John's work, that's what he got down to, and then Nikki's work, she finished up to here. So what we'll do is we will finish both of the methods and see if we get the same answer. All right, so just once again to note here, the slope was negative 2, and the point that the line was going through was 3, negative 5. Okay, so John was using y equals mx plus b, and he knows that the slope is at negative 2. So all he really did here was negative 2 times x plus b. And what he can do further is, because he has a point on the line, he has x, y, he can use that information, plug it into x and y here into the equation. So basically he can put in y is negative 5 and x is 3, and then he can solve for b. Okay, so he's going to end up with negative 5 is equal to negative 6 plus b. And then he can add the 6 to both sides. So plus 6 plus 6. And he ends up with 1 for b. All right, so now that he solved for b, he can put his equation as y equals negative 2x plus 1. All right, again, he got this negative 2. That's the slope right from here. And we just calculated the value for b by plugging in the point for x and y right into the equation for y and x. Okay, next was Nikki. And Nikki was using the slope point form. So she used y minus y1 equals m x minus x1. All right, so for y, that becomes y minus negative 5. And our slope is negative 2, and then x minus 3. Y minus negative 5, we just show it as y plus 5. She had stopped her equation right here. So y plus 5 equals, I'm just going to multiply this out, negative 2x and then plus 6. And now I'm just going to subtract 5. And we end up with the exact same equation. All right, so two different methods were used, but we do end up with the exact same equation. Okay, in this example, we are given a graph, and we are given the line on the grid passes through at least 2 points with integer coordinates. Determine the equation of the line in general form. So I'm just going to choose 2 points on this line. I can use this point here. So that's negative negative 6 and 0 for that point, and I'll use this point here, and that point is at negative 2, negative 3. So those are the 2 points on this line. So we can use what we know of slopes and formulas. We can use 2 points to figure out the equation of a line. In this specific case, we're putting it into general form. So using those 2 points on our line that we saw in the graph, we can calculate, first of all, we can calculate our slope. So remember, slope is rise over run. We subtract our y points divided by, we subtract our x points. So we can subtract negative 3 minus 0, and then negative 2 minus negative 6 to calculate our slope. So put that into your calculator, and we get a slope of negative 3 over 4. All right, so once we have our slope, you can now choose one of the points. You can choose either point to put into our slope point form. So let's choose negative 6 and 0. So using that, we'll get y minus 0 is equal to negative 3 over 4, and then x minus negative 6, which is x plus 6. All right, so here would be our equation in a slope point form. All right, but the equation does need to be put into general form. That is what is required. So let's do that. So we have to get rid of this fraction here. So that means we have to multiply the whole equation by 4. So I'm just going to show here that I'm multiplying, just multiplying by 4 and multiplying by 4. Multiply both sides. So on the left-hand side, we end up with 4y. I'm just going to show that in one more step here. So 4y minus 0, and these will cancel out like this, and we'll end up with negative 3 multiplied by x plus 6. All right, and now I'm just going to pick that up here. So multiplying this out, 4 times y is 4y, 4 times 0 is just 0. And then on our right-hand side, negative 3 times x, that's negative 3x, and negative 3 times 6 is negative 18. All right, in general form, remember that we need our x to be positive, so we're going to have to move everything on our right-hand side, move it to our left-hand side. Okay, so add the 3x and add the 18. So we end up with 3x plus 4y plus 18 is equal to 0. All right, so that's our equation in general form. In these next examples, we are given the equation of a line in slope point form, and we have to state the slope of the line and the coordinates of a point on the line. So slope, we know, I'm just going to write the equation up top again. The y minus y1 equals m, x minus x1. So that's our slope point equation. So looking at our first example, this is our slope right here, our little m. So our slope is 1 over 7. And a point on the line, so that's our y and that's our x. But remember, our points are going to be opposite to the signs here. So our point is going to be 4 and negative 11. All right, because if we now work backwards, It was y minus negative 11. That's how it became positive 11. And then x minus 4. So positive 4, negative 11. Our next example here, y minus 9 equals negative 5 over 3, x minus 7. Slope is easy to find. It's right here. So our slope is negative 5 over 3. And our point on a line is going to be positive 7 and positive 9. Okay, so looking at the next example, so example C, our slope is still here. Our slope is negative 3. And here we don't have another point for our y minus y1, so it would be 0. So our points for a point on the line would be at positive 6 and 0. All right, here, this is in our y equals mx plus b form. So what we know here is our slope is at negative 3. And a point on the line, because this is our y-intercept, our point on the line would be at 0, negative 6.